All right, so we've already dealt with B, we've already dealt with C, and the only thing that's left over is A, guys. That's it. So let's look at A here. So we did that, we did that. Let's look at A. Now for our A, this is going to deal with like telling whether the graph is going to really like kind of shrink or expand, like it's going to getting wider, getting skinnier, that type of stuff. But instead of us using the words wider and skinnier, we're going to use things called like vertical stretching, vertical shrinking, horizontal stretching, horizontal shrinking type stuff. Simply because that's what math does. All right. So here we're going to take a look at our A, and first off, we're looking to see where A is in front of the function. So again, this is when A is in front. I just say in front of the function. All right, so this happens when A is in front of the function. Ah, sorry about that, guys. Huh. So here, when A is in front of a function, we have a vertical stretch or vertical shrink that's going to happen. And depending on what's going on, it depends on whether it shrinks or expands. So if A is greater than 1, we have a vertical stretch by a factor of A. So we say it's going to vertically stretch by whatever A is. All right. The second one is going to be like, let's say A is between 0 and 1. So that means that's like a decimal number. That's a fraction that's between 0 and 1. Anything that's between 0 and 1 is a vertical shrink by a factor of A. Now, with this, as we're looking at it here, vertical shrinks and vertical stretches with the factor portion here, it's going to be kind of important that you pay attention to like which one to do. So if it's this one, you just write A. So like if A was 5, you would say vertically stretches by a factor of 5. If it was like 1/2, you would say a vertical shrink by a factor of 1/2. So that one's easy. You just look at it and be like, tell me what it is. All right. Now, when A is on the inside, so here A is on the inside this time of the parentheses. So A is inside of a function. Oh, blurry. Fix it. All right, so when A is on the inside of a function, it's going to be a horizontal stretch or shrink of a function. So this is with A again. All right. Now this time it's going to be a little opposite. So before we said that if A was greater than 1, it was a vertical stretch. This one is a vertical stretch. It's going to actually be between 0 and 1. And again, guys, you're just going to have to remember this. When it comes to a test, maybe I'll let you use your notes on this part because this one can be kind of tricky. Thinking about what's going on. But this is going to be, the function is going to horizontally stretch by a factor of 1 over A. Right? And then if A is greater than 1, the function will horizontally shrink by a factor of 1 over A. So in other words, whenever we deal with it, we're going to really be dealing with fractions. So for this part here, for the most part, you're going to be dealing with a fraction. The first one might be a whole number, but the second one will definitely be a fraction. All right. So again, we have it when A is in front and when A is inside. And again, with this, we're going to work on it. We're going to try it. We're going to make sure you guys understand what's going on the best that we can. All right. So here, the last thing before we actually go to an example, it's dealing with the negative that's in front. A negative, not necessarily just in front. We have a negative here that's in front, and we have a negative here that's inside. All right. So here, if we have a negative that's in front of the function, in front, that means it's going to flip about the x-axis. Right? And when we talk about flipping about the x-axis, that means here, I'll put it right here on this side. We're going to flip about the x-axis. So that means here, just like we did before, we did the parent graph was actually a dotted line. So I'm going to do quadratic right now. This is f of x equals x squared. All right, so if we're going to flip it about the x-axis, my solid line, my solid graph is going to be coming down this way. It's going to open down because it flips about this line right here. So it's going to open down. Always going to open down. All right, I'm going to give you another one too here, and it's to do with our cubic graph. All right, so this is our cubic graph, f of x equals x cubed, which everybody knows their parent graphs because we wrote them down from the notes. All right, so if we're going to flip about the x-axis, again, we're going to flip about this line right here. So we're going to rotate it this way. So in other words, we're rotating it going around this way. So everything rotates around this way, like the way a wheel goes around this way. All right. So with that, that means if it goes around that way, this is going to come down. This whole piece right here is going to come down. So coming down this way. And this whole piece right here is going to just flip up. And it's going to go this way. Okay, so that's where we're talking about flipping about the x-axis. So if it's here, it's going to flip down. If it's here, it's going to rotate around there. And this part's going to come down. This part's going to go up. Guys, it can be confusing a little bit for this part, the flipping part and graphing it. But guys, I promise you, I'm going to take care of you on this. I got you. I got you. All right, the other one is that the negative's on the inside of the function. It's going to flip about the y-axis. So that's this one right here. All right, we're talking about flipping about the y-axis though. This one, it depends on the function. It's very similar to like what we did for flip up the x-axis, but it's a little similar. All right, so I'm going to come here. I'm going to again do my parabola. All right, so when we do this and we're talking about flipping about the y-axis, that means we're looking at this axis right here, and we're going flipping it around this axis. So we're rotating it around that axis. Ooh, that got really blurry. And it's still blurry. Right? So it's rotating around that axis. Let's see, maybe if a different color will help. Not really. All right, so we're rotating it around like that. So that means here, the function normally is like this, but if we flip it around going this way, it's really going to go back on the same thing again, guys. So this one's going to flip over here, and then this one's going to flip over here. So it's really going to be the exact same graph. So normally when you flip about the y-axis, really, if it's like this symmetrical, it's going to be the exact same graph again. But when it comes to this part here, flipping about the y-axis, so here, a y-axis, let's say cubic graph. For flipping it again around the y-axis, right, so if it's flipping about the y-axis there, it's kind of doing the same thing they did over here. This one's going to flip over here on this side. This one's going to flip over on that side. So here it's going to go up here. Oh, go up that way. And this one's going to rotate over here. So it's really the same graph as that one. But yeah, that's how it's working. All right, so let's get to our examples really quick, and then we're going to go ahead and get into putting everything together. So example 4, this time we're not going to graph it. All we're going to do is just tell the parent graph and list the transformations. So there's no graphing this time. Whew. All right, so first off, we're going to take a look at the parent graphs for each one of these. So we know this is quadratic. We know this is cubic because it's a 3. We know this is quadratic. And there's actually a D also, and we'll do that next on the next page. All right, so we have those 3. All right, so with this again, the negative here, that's in front. So since it's in front, that means we're going to be dealing with flipping about the x-axis. All right, and then we go ahead and take a look at the number. And as you can see, the number is in front of the function. So it's in front of it. So that means we're dealing with these. And it's 5. So it's greater than 1. So that means we're going to do a vertical stretch by a factor of 5. So it vertically stretches by a factor of 5. Again, because the negative is in front. We flip about the x-axis. When it comes to here, it's a 5, and it's in front of the x. All right, same thing is happening here. There's no flip, so we don't have to worry about that part. So no flip, because there's no negative. All right, and then we have that 1/2 is in front of the function. So here, if it's again in front of the function, that means between 0 and 1. That's 1/2 is between 0 and 1. That means it's going to be vertically shrinking by a factor of a vertical shrink. All right. Then we're going to come to C. And this time, again, there is no flip because there's no negative. No negative, no flip. 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 Okay, so again, if there's no negative, we don't flip. All right. So the last part is with this one is looking at, okay, the 5 is inside the parenthesis this time. So it's inside. So it means we have to look at this portion right here, the inside. And we say it's 5. So that means 5 is greater than 1. So we're looking at it's going to horizontally shrink. And we're going to say by a factor of, and we say that's 1 over a. So here a is 5. So that's 1 over 5. So see, it's not that bad. It's still something you have to remember, but it's not that bad. All right, and then we have one last one here, and we're going to do example 5 in another video. But one last one here is going to be, again, cubic. It's going to flip. It's a negative on the inside, so it flips about the y-axis. Oops, wrong color. That's okay. But then here it's 1/2 on the inside, so it's going to horizontally stretch.